This demonstration is very similar to the whoosh bottle we all know and love. The smaller scale makes this rocket version safer, but it still involves a highly flammable mixture as well as a flying projectile, so you should make sure that the risks have been carefully assessed before you start. You will need a 1.5 to 2 litre fizzy drink bottle. To prepare it, make a hole in the bottom of around 5 to 6 millimeters. You can use a drill or a hot object to melt it. You will also need a rubber bung that will fit into the hole. Once the bottle is prepared and you're ready to go, put a small amount of ethanol into the bottle. IDA or methylated spirits is fine. You will only need about 1/2 to 3/4 of a milliliter. Adding any more doesn't help. Add the ethanol, put the bung in, and then shake and turn the bottle for a little while to make sure all the ethanol has vaporized. By far the safest way to carry this out is to fly your rocket along a wire. In order to reduce friction, we're using nylon fishing line. Now you will also need a runner to attach the bottle to the line, and we're using some glass tubing, again to reduce the friction. The line needs to be stretched tightly between 2 points. I usually just screw metal cup hooks into the door frames and use those. Make sure you slip the line through the glass tube before you fix it in place. Then, attach the bottle to the glass rod using sellotape. Make sure that the end with the bung is facing backwards and that the end of the glass rod is well back from the lid end. The impact can compress the end of the bottle and we don't want the glass breaking. Once done, wear eye protection to be on the safe side, remove the bung and bring up a flame to the hole. A splint or a lighter like the one used here is ideal. The rocket hurtles along the wire and thumps into the wall at the other end of the room. With a small amount of extra effort, it is possible to calculate the speed and acceleration of the rocket. From there you can work out the energy needed for the acceleration. Then, with a few further assumptions and approximations, you can work out the amount of energy produced from the combustion of the ethanol, and from there get a rough calculation of the efficiency with which the rocket converts chemical energy into movement.